6.4 Properties of Rhombuses, Rectangles, and Squares. In this section, we're going to be looking at special cases of parallelograms. And remember, parallelograms are quadrilaterals. They have four sides, with their opposite sides being parallel. The first special case we're going to look at is the rhombus. The rhombus is a parallelogram with four sides being congruent. So in your parallelogram, it must be true that all four sides are congruent. Basically, it is an equilateral parallelogram. So let's write that down because it sounds pretty important. An equilateral parallelogram. The next special case is a rectangle. A rectangle is a parallelogram with four right angles. Since all of the angles are congruent, that would make it an equiangular parallelogram. And our last case is the square. A square is going to be both equilateral and equiangular. So all four of the sides must be congruent and all four of the angles. So this is equilateral, and it must also be equiangular. All right, let's take a look at this Venn diagram. This Venn diagram shows the special types of parallelograms. In the first red circle, you have the rhombuses. Okay, remember rhombuses are the equilateral parallelograms. Okay, so all the sides are congruent. Rectangles are all the angles are congruent. Okay, the place where they overlap, okay, these are your squares because they are both equiangular and equilateral. So this is just a visual of what's going on. Example 1 is parallelogram ABCD a rhombus, rectangle, or a square, and we want to explain why. If we take a look at the information in the picture, we see that angle B is a right angle. Since it is a parallelogram, we also know that its opposite angle, angle D, is also a right angle. Again, since it's a parallelogram, we know that angles D and C must be supplementary. And if angle D is 90 degrees, in order to add up to 180, angle C must also be a right angle as well, and C is opposite of A. Since all of the angles are right angles, we're looking at an equiangular parallelogram. So it is a rectangle. Okay? We do not know enough information about the sides to determine if it is an equilateral parallelogram. Here's our first theorem for the day. It says if a parallelogram is a rhombus, then its diagonals are perpendicular. So if you construct the diagonals of a parallelogram and of a rhombus, then we know that they are going to be perpendicular. Let's think for a minute about the proof because it requires something we learned a long time ago. If you guys remember, if you have a point that is equidistant from the other 2 points, such as B and D, okay, then that point A must lie on the perpendicular bisector of BD. Do you guys remember that? That one's pretty old, but we did learn that several chapters back. So AC would lie on the perpendicular bisector. Similarly, D is equidistant from A and C, so it's going to lie on the perpendicular bisector. Taking this theorem one step further, the converse is also true. So if you know that the diagonals of a parallelogram are perpendicular, then it must be true that the shape you're looking at is a rhombus. So the original statement is true and the converse is also true. Our next theorem states that if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So this diagonal AC is going to bisect this angle here. So therefore, angle 1 is going to be congruent to angle 2. And likewise for the other 3 angles of the rhombus. Similar to the last theorem, the converse is also true. If you know the diagonals of the parallelogram bisect each other, then it must be a rhombus. Example 2. We want to find the measures of the numbered angles in the rhombus. So, let's start anywhere. Let's start with angle 1. Angle 1 is located where the diagonals bisect each other, and we learned from a theorem a couple pages back that the diagonals bisect each other at right angles. So the measure of angle 1 is equal to 90 degrees. Alright, let's take a look at angles 3 and 2 next. We know since it is a parallelogram, because a rhombus is a special case of a parallelogram, that all of angle B, so all of this is going to be equal to all of angle D. And we also know that the angles are going to be bisected. So we do know that angle 3 and angle 2 are going to be equal to 58 degrees. So the measure of angle 2 is 58 degrees. And the measure of angle 3 is equal to 58 degrees. And if you guys can hear that, that's my cat Gracie saying hello. Okay, and for the last angle, there are a couple different ways to solve for angle 4, but let's use the triangle angle sum theorem. We just said that angle 1 is 90 degrees, and we said that angle 3 is 58 degrees. And we know that all the angles must sum to 180 in a triangle. So a little bit of subtraction leads us to the measure of angle 4, which is equal to 32 degrees. This last theorem is talking about a special case for a rectangle. If a parallelogram is a rectangle, then its diagonals are congruent. So if you know you have a rectangle, when you construct the diagonals AC and BD, then those diagonals are going to be congruent to each other. Similar to the other theorems we learned, the converse is also going to be true. So if you have the diagonals, if they're congruent in a parallelogram, then that parallelogram is a rectangle. Example 3. In rectangle RSBF, we know that SF, this diagonal here, is equal to 2x plus 15. We're also told that RB, this green one here, is equal to 5x minus 12. And we want to find the length of a diagonal in this rectangle. Based on the theorem we just learned, we know that these two measures are going to be equal to each other. So we know 2x plus 15 equals 5x minus 12. Subtracting 2x from both sides, 15 is equal to 3x minus 12. Adding 12 to both sides gives us 27 is equal to 3x. Dividing both sides by 3 leaves us with x equal to 9. Now we're not quite done because we do want to find the length of the diagonal, so we can plug x back into either of these equations. So how about 2x plus 15? Let's plug in x. We have 2 times 9 plus 15. And when you multiply and add that together, you should get 33. So the measure of the diagonals in our rectangle is 33. And we don't have any units, but if we did, we should put a unit. Alright, that's it, guys. This was a short lesson. Here are 3 practice problems I want you guys to try and bring to class tomorrow. Pause here and bring them tomorrow.